Okay. So we did this question in the previous class. We have ended over here. So we have observing some questions from the Nernst equation as well. Okay. So let's observe a few more questions. So if you look at this question, the diagram shows the apparatus used to measure the standard electrode potential E naught of Fe3 positive aqueous signs and Fe2 positive aqueous signs. Okay. Identify the letters A to F represents. Okay, it would be easier. Yes, who can identify F? Oh, A. Start with the A. Who can identify A?
Sir, hydrogen gas.
Hydrogen gas. Why?
सर क्योंकि हमने उसका स्टैंडर्ड इलेक्ट्रोड पोटेंशियल निकालना है तो हाइड्रोजन का वो ई वैल्यू 0 होती है.
Bonded. It must be connected to a standard hydrogen electrode. So whenever we have to find the standard electrode potential of any of the half cell like this, so we always use this hydrogen standard hydrogen electrode. Okay. So here we would write hydrogen gas, and as we are finding the standard conditions, so it would be 1 atm. Then move to the B. Yes, who can tell me B? Platinum. Then what about C? Yes, हमने C को yesterday we also discussed like this. So if there is a hydrogen gas is getting inside, so C must contains the hydrogen ions. So either you can write hydrogen ions or you can take hydrochloric acid, and its concentration must be 1 mole per dm cube. Okay. Now D is salt bridge. After D we have a E, again platinum. And why we are taking platinum over here? It's because the solution have a Fe2 positive ions and Fe3 positive ions, both. And when there are ions, in that case, we always take the platinum as our electrode. Is this understandable? Yes, is this clear to everyone? Now let's start. Label. Okay, label the diagram to show which is the positive electrode and the direction of the electron flow in the external circuit. So I think how many times we have did for Fe2 positive and Fe3 positive? I think now you guys also remember that its E naught value is 0.77 volt, right? And the E naught value for hydrogen is 0.00 volt. Okay. So which one have a greater value? So it means here reduction would occur and here oxidation would occur. And in oxidation, what happens? Loss of electron. So those electrons start traveling from here, which makes it this one a negative terminal. So these electrons travel from here, reaches there, and then so this makes this a positive terminal. Okay. So label the diagram, the direction of which is the positive electrode. Okay, we have labeled the positive electrode and the direction of the electron flow in the external circuit. So we have mentioned the direction of the electrons in the external circuit as well. Is this clear? Okay. Now, in another experiment, an Fe3 positive, Fe2 positive half cells was connected to Cu2 positive Cu half cell. Determine the standard potential E naught cell. Which of these half cell are connected by a wire when the circuit is completed? Use the data booklet to help you. Okay, we know its value is 0.77 volt, right? Now let's have a look at the value of a copper to positive. Here it is, right? And why I'm choosing this equation? If you see over here, it's a copper metal and a copper to positive ion. So we take the equation which have both of these species, so copper metal and a copper to positive, and its value is positive 0.34, right? Its value is positive 0.34. Where is the ion? Okay. So its value is positive 0.34 volts. Now, if we observe these values, what we can conclude that here the reduction would occur and here the oxidation would occur, right? So E naught cell would be E reduction minus E oxidation. So 0.77 minus 0.34. So isn't it positive 0.43 volt? Yes, is this understandable to everyone? जी यहाँ तक क्लियर है सबको? Okay, now next part. The E naught of the nickel to positive and nickel is minus 0.25 volt. Okay. State and explain how the electrode potential changes if the concentration of nickel to positive ion is decreased. Okay. So if I'll write the equation, as we know, the equations must be in the reduction and its value is minus 0.25 volt, right? So if I decrease its concentration, what would happen to the equilibrium? Equilibrium shifts to left, and if the equilibrium shifts to left, the E value now becomes more smaller, or you can say more positive or more negative. Okay, so the electrode potential gets more negative because of decrease in concentration of nickel ions, equilibrium shifts to left hand side. Is this understandable to everyone? Yes, if anybody have any confusion, do ask. Next part. The E naught of chromium is minus 0.41 volt. Calculate the electrode potential when chromium concentration is mole per dm cube and when the chromium 2 positive is 1.5 mole per dm cube using the next equation. Okay. So first we would look at the half equation. In this half equation, so this would be my equation. And this one is the oxidized species because its oxidation number is greater. And this is the reduced. Yes, is this clear? So we know the concentrations. Now we have to put the value. The E naught is minus 0.41 plus 0.051 over 1. So log 1 electron है, so we take a 1. Oxidized species is Cr3 positive, its value is 0.60 divided by yes, you can solve it and find the half cell of electrode potential. क्या आ रहा है आंसर? -0.374. ठीक है, ये क्लियर है सबको? इस तक किसी को कोई कंफ्यूजन तो नहीं है? Okay, how you will do this? Read the question carefully and tell me how would you do this. The E naught for a lead-2 positive aqueous and lead metal electrode is 0.13. Suggests how the E for this electrode would differ from its E naught value if the concentration of lead ions is reduced. Yes.
सर जब उस आयन की कंसंट्रेशन कम होगी तो इक्विलिब्रियम विल शिफ्ट टुवर्ड्स लेफ्ट, उसकी वजह से जो उसकी ए नॉट वैल्यू होगी वो मोर नेगेटिव हो जाएगी.
ठीक है. Okay, so it means for this reaction the lead positive aqueous meaning 2 electrons forming lead and as the concentration of lead is reduced, so equilibrium shifts to right, sorry, shifts to left. So and the E naught value gets even more smaller, so we can say more negative, right? इसे क्या consider करेंगे? More negative consider करेंगे. Okay, explanation में हम काम करेंगे. 1 मार्क आपको ये टिक करने का मिलेगा, दूसरा मार्क एक्सप्लेनेशन का मिलेगा, तो आप वहां पे यही लिखेंगे कि इक्विलिब्रियम शिफ्ट्स टू द लेफ्ट. और इक्विलिब्रियम आप चाहे तो यहाँ पे इक्वेशन भी लिखवाते हैं. आप जस्ट अगर ये बात लिखेंगे तो ये बात बहुत ही वेग हो जाएगी कि किस इक्विलिब्रियम की बात हो रही है. Okay. अच्छा ये जरा कंप्लीट कीजिए. जाके बात करेंगे पहले क्वेश्चन कंप्लीट करें. एक मिनट. The कौन सी इक्वेशन है? It's an half equation. It's not the complete equation. And taking place at the positive electrode. And if it's taking place at the positive electrode, whether there is oxidation or reduction. Reduction. Half equation means we have to show the equation that is there at the electrode, and they have mentioned you that it's a positive electrode which means reduction, so you have to show the gain of electron. These are the half equations. Yes, can anybody complete this half equation? Okay, then have a look. What you do, first find the oxidation number. If you see, the net charge is 0, right? And it's -2 times 2, making it -4. So the lead have a +4 oxidation number over here. And if you look over here, that it's -2. So the lead must be +2. So what we know that there are 2 electrons are gained. So 2 electrons. The other half equation is this, okay, which is occurring at the negative electrode. And then, and that part we already have done to find the quantity of the substance. Okay. So now, what would we do next? Yes. Any guesses? Okay, let me tell you what to do next. This sulfate is over here, right? And we are left with these oxygen. So normally, if there is oxygen, so you just make a water, and to balance the water, the hydrogen you would place a 4H positive.
Sir?
So this is यस।
सर जो हमारे पास डेटा बुकलेट है उसके अंदर जो इलेक्ट्रोड रिएक्शंस है उसके अंदर हमारे पास ये वाली इक्वेशन है PbO2 प्लस 4 हाइड्रोजन प्लस 2 इलेक्ट्रॉन्स मेक्स Pb2 प्लस और 2H2O।
ठीक है,
तो अगर हम उसको इसमें पुट करें तो फिर भी सेम ही आंसर आ रहा है, तो क्या हम वो कर सकते हैं या फिर वो किसी पॉइंट पे जाके नहीं काम करेगा?
वो किसी पॉइंट पे जाके नहीं काम करेगा, एक बात। और दूसरी इंपॉर्टेंट बात, अब तो डाटा बुकलेट आपको मिलेगी नहीं। अब तो डाटा बुकलेट मिलेगी नहीं, और अगर कोई क्वेश्चन होगा ऐसा
ठीक है सर, ठीक
जिसमें
है।
आपको यूज करनी है, तो वो आपको पूरी लिस्ट थोड़ी देगा 2 पेजेस की, वो सिर्फ आपको 3 या 4 सिलेक्टिव इक्वेशंस प्रोवाइड करेंगे आप। ठीक है,
जी
तो
सर,
अब तो
ठीक है।
डाटा बुकलेट का तो ऑप्शन ही खत्म हो गया ना। तो
ठीक है
इसलिए
सर।
मैंने डाटा बुकलेट मैंने भी ओपन नहीं किया, आपको इस तरह समझाने की कोशिश की कि आप इसकी हेल्प से करेंगे। ओके,
सर ये
नाउ
बॉन्ड एनर्जी वगैरह गिवन होंगे फिर हमें?
जी, मैं वही बता रहा हूँ। देखें होगा क्या कि डाटा बुकलेट आपको पूरी प्रोवाइड नहीं की जाएगी, बट फॉर एग्जांपल लेट मी टेल यू कि अगर कहीं पे हमारी रिक्वायरमेंट है, ठीक है, तो फॉर एग्जांपल अगर लेट सपोज कि क्लोरीन और आयरन का उन्होंने बताया एक हाफ सेल है, उन्होंने बोला एक सेल है जिसमें क्लोराइड और क्लोरीन है, और दूसरा क्या है, आयरन 2 पॉजिटिव और आयरन 3 पॉजिटिव है लेट सपोज। तो वो आपको उस क्वेश्चन के साथ टेबल में ये 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 और फिर ये 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 इस तरह 8 to 10 कलेक्टिव इक्वेशंस आपको दे देगा। मैंने अभी सिर्फ वो इक्वेशंस को किया है जिनको जो है मैंने अभी टिक किया है, सिर्फ उनको आप देख लें, क्योंकि उन दोनों में क्लोरीन और आयरन प्रेजेंट है। ठीक है, ऊपर वाली तीनों इक्वेशंस में क्लोरीन है, और नीचे वाली all these 5 equations have iron in it. So examiner can provide you these values or these half equations. तो इस तरह आपको कुछ ना कुछ साथ प्रोवाइड करेगा।
ओके सर, यस।
ओके, next part. The diagram shows how the voltage across two different cells changes when with the time when each cell is provided to an electric current. Okay, suggest a reason why the voltage of a lead acid cell changes after several hours. And in hydrogen oxygen fuel cell, they remain constant. Yes, who can answer? Yes, can anybody tell me the answer? It's very easy and nothing to do with the chemistry over here. Okay. What is written over here? Fuel cell, and it is continuously giving you a equal voltage. It means that the fuel is supplied continuously. And the fuel doesn't run out. Fuel is supplied continuously. Okay, and this fuel is hydrogen over here. Well, if you recall, any one of you know the use of lead acid cell, where they are used? These are the car batteries. These are the car batteries. So there is no fuel over here, and after the time, the reactants in those car batteries must be used up, or their concentration decreases, so the voltage decreases. So the reagents yes, are these 2 points are clear to everyone? Okay, now have a look over here. An electrochemical cell consists of a half cell containing V3 positive and V2 positive ions. So this is one half cell, okay? And another half cell containing VO2 positive and VO2 positive. This is another half cell. Okay. Use the data from the data booklet to calculate the value for the E0 cell. Okay, we'll do it. Look at the next part, write the ionic equation for the cell reaction. So how could we make the ionic equation? If we know both the equations and we already have decided in where the oxidation takes place, where the reduction takes place, and then we balance the electrons and add up, right? But here I want you, before heading towards the data booklet, I want you to make the half equations first by the information provided over there. So see, it's very easy. If we talk about the first half cell, let's suppose, what species are there in the first half cell? Yes, vanadium 3 positive and 2 positive. So vanadium 3 positive is converting into vanadium 2 positive, and how it could be done? By gain of 1 electron only. So my half equation is ready, and you don't need to, because you are provided with both the equations, so you can make the half equation. Okay, now let's try to make the half equation for the second half cell. In the second half cell, here I have VO2 with a positive charge, and here I have VO with a 2 positive charge. So what is the oxidation number over here on vanadium? Isn't it +5? Yes, the oxidation state of vanadium over here is, there are 2 oxygen making it -4, and the net charge is +1, so it's +5.
सर +3 नहीं होना चाहिए?
बेटा नेट चार्ज +1 आ रहा है ना,
अच्छा हाँ सही है.
and here the net charge is 2 plus. So there is one oxygen which is -2, so it must be +4. So +5 to +4. Again, there is a gain of an electron. So it would be like this. So see, I have made both the half equations without. So you must know that how to make the half equation on your own, okay? So now when I look into data booklet and find their values, then I decide that which half equation would be flipped, because both the half equations are written in terms of reduction, right? So let's move over here. Vanadium, vanadium, vanadium. So one is this one. Okay, there is one problem in this half equation that I have missed to discuss. See, how many oxygen over here? This half equation is not yet complete. Why? Because the elements are not balanced. So how many oxygens are over here? How many oxygen are over here? One. So it means I have to place one more oxygen over here, and I made it by putting a water over here. And to balance those water, I have to put a 2 moles of hydrogen ions over here. Yes, is this understandable? So this is the half equation. Now let's have a look at the E naught values. Minus 0.26. This one have a minus 0.26 volt, and the other one is this one, right? And it have a positive 1 volt. इसकी क्या थी? पॉजिटिव 1 थी। तो इससे हमें पता चल गया that here the reduction may occur and here the oxidation may occur. So E naught cell is equals to 1.00 minus 0.26. So it is 1.26 volt. Okay. Now draw a free label diagram of the apparatus you could use to measure the potential of the cell, including the necessary chemicals. Now, see, we have to show the diagram to measure the potential of this cell, right? Okay, first I didn't make that equation. So this is the oxidation. So I would first flip this equation. So if I would flip this equation, then it would be V2 positive over here and V3 positive and plus electron over here. Both the equations have a 1 electron. So these electrons are get cancelled, and the equation is 2H positive plus V2 positive plus V2 positive, forming VO2 positive, V3 positive plus H2. Right? So this is the net ion equation. Draw a fully labeled diagram of the apparatus you could use to measure the potential of this cell. This cell K, you have to draw the diagram, and this cell have a 2 of these half cells, right? So there we put a salt bridge. So it's like this. Now you have to label it. Okay, no, there is no battery. There must be a voltmeter over here. What about the electrodes? Which material these electrodes are made of? And for vanadium oxides, in both the species we have ions. In both the half. No platinum. The electrode is, I am talking about the electrode. I am not talking about the electrolyte. Electrode are both the electrolytes are platinum. In the first half cell, we have V2 positive and V3 positive. Here it could be hydrogen ions because VO2 positive ions and VO2 positive ion. No. So each one of them are 1 mole per dm cube. Is this clear? This is clear to everyone else? Okay. Now, all of you have a data booklet. Use the data from the data booklet to predict whether a reaction might take place when the following pair of the aqueous solution are mixed. If a reaction occurs, write an equation for it and calculate E naught cell. Okay. And if the reaction does not occur, so you would write no reaction. Okay, so look at the first case. We have a data booklet. Yes. Do everyone have a data booklet? Okay, try. Complete it and then WhatsApp me, okay? Why you guys are complete both the equations if possible. Draw it and WhatsApp me as soon as possible. The next part. Yes, how many of you have completed these two? Okay, Sanya, I received yours. Let me see. Okay. Only Sanya have sent me. Okay, Sanya, very good. Now do it the second for the second equation as well. Okay, Salih have sent me. Very good, Saliha. Sanya, you didn't, calculated the not value. Okay, remaining student, please send me as soon as possible. ये और किसने कर लिया भाई? Okay, that's good. So, Sanya. Now do the second part. Yes, please WhatsApp me as you complete it. Okay, Arsh. Yes, who else have completed? Yes. Yeah, the reaction occur. And which one is undergoing? Why took 10 to positive beta? See the question. Yeah. You don't take the equation for the for positive. Here it is. So you would use this equation. So in this case, tin 4 positive reacts with 2 moles of vanadium, 2 positive ions forming tin 2 positive and 2 moles of vanadium, 3 positive. Right? Now, if you look at the half equations of these two, this have a value of positive 0.15 volt and V2 positive have a value of V2 positive and V3 positive minus 0.26 volt. So E naught cell, yes. Okay, that is space for the buffer. And we have made the equation 10 2 positive plus 2 positive और E नॉट सेल क्या होगा 0.15 माइनस 0.26 यहाँ तक क्लियर है सबको? Okay. Next we have a VO2 positive. This one and here this one. With the iron 2 positive. Okay, iron 3 positive. So we know if you recall the half equation, iron 3 positive gaining 1 electron turns into iron 2 positive with the value of इसकी E नॉट वैल्यू क्या थी पॉजिटिव 0.77 थी ना। अच्छा, अब अगर आयरन 3 पॉजिटिव है तो इसका मतलब है इसे क्या होना है रिड्यूस ही होना है, तो इसका मतलब है इसे क्या होना पड़ चाहिए, और अगर इसको ऑक्सीडेशन करना चाहिए तो इसकी E नॉट वैल्यू क्या होनी चाहिए स्मॉलर होनी चाहिए 0.77 से। तो ऑक्सीडेशन ये कहाँ पे कर रहा है, यहाँ पे भी कर रहा है, यहाँ पे तो रिडक्शन कर रहा है, तो इसलिए तो कैंसिल हो गई। इन दोनों में VO2 पॉजिटिव क्या कर रहा है ऑक्सीडेशन कर रहा है। अच्छा, और दोनों की वैल्यू क्या है बनी तो है, सॉरी वैल्यू बड़ी है जो कि छोटी होनी चाहिए, तो यहाँ से हमें पता चल रहा है रिएक्शन डज नॉट हैपन। और इस बात को हम जस्टिफाई करना चाहें तो हम ई नॉट सेल कैलकुलेट करके भी कह सकते हैं, क्योंकि कह रहे हैं ये ऑक्सीडाइज हो रहा है और उसकी वैल्यू 1.00 वोल्ट है, और ये रिड्यूस हो रहा है और उसकी वैल्यू 0.77 वोल्ट है। तो अगर मैं so what I was supposed to do, if you would calculate the E naught cell, so it would be 0.77 minus 1.00, so it gives you negative 0.23 वोल्ट। सो नेगेटिव में आ रहा है, does reaction occur? No। हाँ, आप ये भी हमने कैलकुलेशन करके देख ली ना, नेगेटिव है तो इक्वेशन बनाने की जरूरत नहीं है। ठीक है, यहाँ तक क्लियर है?
सर मुझे इसमें कंफ्यूजन है कि VO2 पर ये दूसरी वाली इक्वेशन क्यों यूज करी है,
कौन सी वाली?
जिसमें
एक
E
मिनट
नॉट
आप
0
हाँ अब बताएं। हमने ये वाली यूज नहीं की और इन दोनों में से कोई भी यूज कर सकते हैं।
सर वो वाली क्यों नहीं यूज कर सकते?
वो वाली इसलिए यूज नहीं कर सकते, एक मिनट आयरन पे आ जाते हैं जरा हम, तो आपको बात अच्छे से समझ में आएगी। देखिए आयरन आयरन दो जगहों पे है और हम उसको आयरन से रिएक्ट करा रहे हैं, राइट? तो आयरन इन दोनों जगहों पे क्या कर रहा है रिडक्शन कर रहा है जी सानिया।
यस
तो अगर आयरन रिड्यूस हो रहा है, ये बात तो श्योर है, किसी की हाफ इक्वेशन में आयरन की पॉजिटिव ऑक्सीडाइज हो ही नहीं रहा है ना, और हाफ इक्वेशन में आयरन, तो इसका मतलब है कि वो जो VO2 पॉजिटिव है उसकी वो इक्वेशन यूज की जाएगी जिसमें वो ऑक्सीडेशन कर रहा हो, और फिर हम फर्दर डिसाइड करेंगे कि वो रिएक्शन होगा या नहीं होगा। तो इसलिए ये वाली तो हम पहले ही इसको स्किप कर दिया, क्योंकि आयरन अगर 3 पॉजिटिव है वो फर्दर ऑक्सीडाइज नहीं हो सकता, वो तो सिर्फ रिड्यूस ही होगा। तो इसका मतलब है VO2 पॉजिटिव की वो इक्वेशन होगी जिसमें वो खुद ऑक्सीडाइज होगा। इज दिस क्लियर नाउ?
यस सर।
जी, और किसी को कोई डाउट है, कोई कंफ्यूजन है तो प्लीज पूछ लें।
सर ये लास्ट वाली बात रिपीट कर दें अभी जो आपने बताई थी।
कौन सी लास्ट वाली बात है?
ये आयरन से जो एग्जांपल देके बताई थी।
बेटा आपको रिएक्टेंट जो प्रोवाइड किए गए हैं वो दो प्रोवाइड किए गए हैं। कौन से दो प्रोवाइड किए गए क्वेश्चन में? Fe3 पॉजिटिव एंड VO2 पॉजिटिव, राइट? तो देखें, जो आपको एक रिएक्टेंट दिया हुआ है वो एक रिएक्टेंट तो आयरन 3 पॉजिटिव आयन है ना, ये बात क्लियर है?
यस सर।
तो अगर आप आयरन 3 पॉजिटिव आयंस को यहाँ पे देखें तो वो आयरन 3 पॉजिटिव आयंस यहाँ और यहाँ प्रेजेंट है, राइट? और दोनों केसेस में ये फॉरवर्ड रिएक्शन कर रहे हैं, यानी कि दोनों केसेस में ये दोनों रिड्यूस हो रहे हैं। और आयरन 3 पॉजिटिव कहीं भी हमारे पास लेफ्ट हैंड साइड पे, राइट हैंड साइड पे नहीं है जो कि बैकवर्ड आके ऑक्सीडाइज हो रहा हो। बात समझ में आ रही है बेटा?
यस सर।
तो इसका मतलब है कि आयरन 3 पॉजिटिव तो रिड्यूस होगा, ये तो फॉर श्योर हो गया, उसके पास कोई और चांस ही नहीं है कि वो कुछ और कर सके। तो अगर आयरन 3 पॉजिटिव रिड्यूस होगा तो आयरन 3 पॉजिटिव के साथ जो दूसरी स्पीशीज थी VO2 डिनोमिनेटर में था, न्यूमरेटर में था। जी, जो दूसरी स्पीशी थी that one is that is VO2 positive, right? So if the iron was undergoing reduction and iron on 3 positive is on the left side of the equation, so from the data booklet the other reactant must be on the right hand side of the equation, so that's why we excluded initially this half equation.
क्लियर।
So in these two it is undergoing oxidation, so iron can react with these two, but from the values when we solve it we get the reduction minus oxidation a negative value, which indicates that the reaction wouldn't occur. Is this clear now? Yes sir.
यस सर।
Okay, this is the interesting question. Use the standard electrode potential from the data booklet to calculate the E0 cell for the following reaction. Okay, so it's not in half equation, it's a complete equation. So if you see over here, chlorine is 0, one chlorine becomes -1 and one chlorine becomes +1, right? And rest of the elements does not change their oxidation state. So if you see and find the chlorine over here, if you see one equation, we can use this one. Now I am asking from you guys, can you tell me which the second equation would be used?
Sir, ClO minus plus H2 plus 2E minus 1.
This one. Very good, Mubashir. See, these two equations must be used. See, okay, one have a 1.36 and the other one have a 0.89, so we can easily do it by doing 1.36 minus 0.89 E0 cell. And they have asked you to calculate the E0 cell, so E0 cell would be 1.36 minus 0.89. Sorry. 1.36 minus 0.89. So what is the answer over here? 0.47 positive. So positive 0.47 volt. Okay. The concentration of hydroxide ion was increased and E cell was measured. Indicate how the value of E naught cell measured would be compared to the E naught cell calculated in 2 tick 1 in the table. Now what they are saying that you have increased the concentration of hydroxide ion. What happened to the E naught cell? Now here you can see. Now tell me what happened. These are the half equations. And this is where you guys get confused. As you say, the equilibrium is shifted to the right from the previous equation. But see, the equilibrium is actually shifted to the left. That equation is already flipped. So the consequences will be opposite for the flipped equation. So you have to always look it from the equations where the equations are written in form of the reduction only. The forward reaction is the reduction and the backward reaction is oxidation. So see, if the hydroxide ions concentration is increased, the equilibrium shifts to the left, and as a result, for example, from instead of 0.89, it goes and becomes 0.80. So if I subtract these two, the value will get bigger, right? The value would get bigger. So E naught cell becomes more positive. So what happens to the E naught cell? Here, E naught cell becomes more positive. Is this clear to everyone? Yes. Is this clear or not? So how would we explain? It is because the concentration of hydroxide ion increases due to which the equilibrium, and what equilibrium we are talking about? Hydroxide ions this one. One minute. What was there? ClO negative. Cl negative, H positive. Sorry, not H positive, OH negative. Shifts to the left. Yes, is this clear? Yes, is it clear to everyone else? Okay. Now I think we have already, did so many practice questions from the redox we done with the entropy, we done with the equilibria, we done with the lattice. So in the next class, either probably I will start. Let's see. I was thinking to start the rate of reaction, and then when we wind up the rate of reaction, we will move towards the organic. Okay. So I'm keeping this class over here till. And afterwards, we will have a past paper session at 5:15, or we can start at 5:10. Okay. Okay. Take care, everyone. Allah.